In this video, I'm going to look at the equation y equals the square root of x and consider the domain and the range. So remember, the domain is the set of all possible input values allowed or used. And of course, don't forget the input values, those are the x values, especially since my equation uses an x for the input. And then the range is the set of all possible output values that result from using the entire domain. So really, it's just all possible output values. And of course, that would be the y values, and my function uses a y value here. So I think to do this, like I did for my other example, and check out the other example video I made for the 1 over x equation, is I'll make a table. This time I'm going to make my table be a vertical table. That's actually usually how I like my tables to be, a vertical table. So I'll put x on this side, that would be the input, and y on this side, the output. First thing I'm going to do is I'm going to plug in, maybe a 0. In fact, if you saw my last equation, my last video, plugging in a 0 was actually the bad thing. So let me try that. Remember, we're looking for all possible input values, and one thing to consider is what is not possible as an input or even as an output. And so is 0 possible to plug in? Well, let me try it. So it would just be the square root of 0. And the square root of 0 is actually just 0. If you remember, the answer to this has to do with what number multiplied by itself equals 0. And so 0 times 0 is 0. All right, so that worked. That actually was possible. It wasn't bad at all. So let's try another number to plug in. What should I plug in? Let's plug in a 1. Okay. Well, what's the square root of 1? Again, you got to think about what number times itself gives you 1. Well, what number multiplied by itself gives you 1? 1 times 1 is 1. So this answer is 1. Now, the next one I'm going to try as an input, plug it in, is 2. What's the square root of 2? Now this is a little more difficult. You might think like, oh no, there isn't a number. What number multiplied by itself is 2? There actually is a number, and if you type in the square root of 2 into a calculator, you get a kind of a crazy number, right? It's actually called an irrational number. It's actually approximately 1.41. Now, of course, it does keep going. There's more to it. But if you multiply 1.41 something, 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 something times by itself, you actually get 2. Check it out. So the square root of 2, well, we could just call it the square root of 2, but in decimal form, it's about 1.41. So I'll even say that this one's approximately the square root of 2. So it worked. It was kind of messy, but it is possible to take the square root of 2. In fact, we'll just keep going. Let's keep trying some inputs. What about 3? Can I do the square root of 3? And the answer is yes. Again, it's not very nice. What number multiplied by itself gives you 3? This one's about 1.73. Of course, it's not exactly that. It's a messier or irrational number, but that's okay. We get the idea. Check it out, that the square root of 3 is approximately 1.73. And again, that came out messy, but it worked. It is possible. All right, well, this got a little complicated, but what's the square root of 4? Well, fortunately, square root of 4 is a nice one. Again, one of these nicer ones like the square root of 1. So square root of 4. Well, what number multiplied by itself gives you 4? 2 times 2 is 4. And so this was totally fine. This is exactly the square root of 4. It's 2. That was nice. In fact, I could keep going and trying all kinds of numbers here. In fact, let me scroll a little bit, give myself a little more room here. I could plug in a 5, but the square root of 5 isn't exactly nice. Just to speed things up here, that's about 2.24. Check it on a calculator. But maybe I should skip down to some nicer square roots. I mean, it looks like I can pretty much square root anything, maybe. Well, what's the square root of 9? That one's another nice one, right? 3 times 3 is 9. And so the square root of 9 is 3. So I keep plugging all these numbers in, and I keep getting answers out. And, I mean, really, technically, I could keep going. I could skip around and try and find some nicer ones. I could do the square root of 10. It's going to be like 3 point something. But if I skipped farther on, what would be another nice one? Well, like 16, square root of 16. That's just 4, because 4 times 4 is 16. And so really, if you think about this, like what numbers could I plug in? I feel like I could just keep plugging in more and more numbers. I could keep going forever and just plug in anything, all the way up to infinity. I could plug in like 9 million and do the square root of 9 million. Well, that would just give me some other answer, some bigger number out. It looks like the bigger the number I plug in, the bigger the number it comes out. Okay, so is anything possible? Remember, it's the set of all possible inputs. That's the domain. And the range is the set of all possible outputs. Well, what's not possible? Well, what I didn't plug in yet are negatives. What is the square root of -1? Well, let's do a quick thought here. Maybe you've heard about this type of situation before, but I'll do a quick explanation. What number times itself is -1? A lot of people think about this. They think, oh, well, it's just -1 times -1 is -1. Wait, no, it's not. -1 times -1 is +1. We want to get -1. That didn't work. Okay, well then maybe it's +1. 1 times 1 is also +1, but we want -1 here. This doesn't work. You cannot do -1 times +1 because it has to be the same number to give us -1. So this isn't working. It has to be the same number to do it. So there isn't an answer here. And if you've heard about it, this is actually called the imaginary number. So this is imaginary. And that's a little weird. So what I might say here is for our domain, this gets a little weird. We have to use our imagination to actually get an output. Maybe we shouldn't be allowed to plug in negatives. Maybe we shouldn't even try to plug in like -2 or -3 or like -4. That would actually be, if you know your imaginary numbers, this would actually be 2i or 2 imaginary. Here's what I want to say though. For the sake of this problem, for the sake of our domain and our range, I think this gets a little too weird. I don't think we want to use these as inputs and get imaginary numbers out. So what we're going to say is our domain for this is just going to be the positive numbers, in fact, starting at 0. So remember, one way to think of it is the domain, we want to start at 0, and we're going to go all the way. Well, how far did we go for plugging numbers in? We were even saying we can kind of go to infinity. So you know what? Maybe I'll just say that our domain is from 0 up to infinity. Now, if you remember, we usually write it in a more official way. We use inequality notation. And so 0 is our starting value, and we could equal that. And then the largest value is actually, well, infinity, which kind of isn't a largest. It just keeps getting bigger. Notice I don't put an equal sign here because we say in math that you can never equal infinity, so we don't put an equal sign there. Infinity just keeps getting bigger and bigger and bigger because we could keep plugging in bigger and bigger numbers. So this would be my domain. My domain for this function, the y equals square root of x, would be from 0 to infinity. Well, what's the range? Well, the range is usually a little more difficult to think about. Well, as we use our domain, in fact, let me scroll back up. Remember, the range is the set of all possible output values that result from using the entire domain. Well, if our domain starts at 0, what does our range start at? Looks like 0. As our domain gets bigger and bigger and bigger, what happens to our outputs? What happens to our range values? They also seem to get bigger and bigger and bigger. Now notice our domain goes all, like we wrote it all the way up to 16, yet the range was 4. Well, I think if we put in bigger numbers, like let me get rid of this infinity for a second. If we plug in like 100 as the input, what would the output be? Well, the square root of 100 is 10. I mean, that definitely got bigger. So if we just plugged in like a ginormous number here, right? 999999999. Like what would be the output? The output would probably be a bigger number. So I'm thinking as our input goes to infinity, I think, it gets bigger and bigger. I think our output could also just keep getting bigger. So I think our output isn't going to like top out and hit a maximum value because we can keep plugging in bigger numbers. So we're probably going to get out bigger numbers. So I feel like my range is going to start at 0 because I don't think I can get a number smaller than 0 out because we'd probably have to plug in a number smaller than 0 in. So I'm thinking my range is also going to be from 0 to infinity. And of course, we write that in inequality notation like this. But remember, since it's the range, it's the outputs. So we use a y value there in our inequality notation. So now we have our domain and range for this square root of x function.